We're destroying these poor creatures faster than ever before.
Confidence? Well, I'm proud of my dishes.
Well,
She's a pretty hip cat.
No matter how cunning and crafty they are, Chief O'Hara, eventually all criminals commit the same error, overconfidence. Let's go, Robin.
The result? A profound taste with just a magical sprinkle of salt. Fifth is maitake and turtle stew.
I really just came home to change into a turtleneck.
Seymour! Set!
In the morning. Oh, Mom? I'm borrowing your car.
Seconds. If this were really a nuclear war, we'd all be dead meat by now.
I've never seen his.
He looks more like a worker in an anti-radiation suit.
Yeah.
Ahmed had financed films before. He was interested in motion pictures himself and the moving image.
If this keeps up, soon you're going to be able to buy that big house Jonathan was always promising you.
There! Pretty as a picture! Ah! Zombies!
Okay.
Maybe I better go talk to him.
Right!
Hello, Crushing Ceiling. Good to see you. Hello, Rishinaka. Hello, Mad Moose. Welcome to another one of these. Excuse me. Okay, that looks fine. So, Where to begin? Actually, we'll start here. Hey, hello. Welcome. We are adding an engine to ScumVM, which happens to include most of the Macintosh API, or rather a simulacrum of it. I skipped last week's stream, but essentially we've done a couple of puzzles and we also did the introduction. All of that so far was pretty basic. It just required being able to draw primitives like rectangles, lines, and so forth. And also being able to draw pictures to the screen in the Macintosh PICT format. And that wasn't too bad. Like, for the most part, the PICT format is kind of a opcode based format, so like here is the thing that I've been working on that we're going to get to, but essentially it's kind of a macro language. You can go ahead, turn on open a picture and then just do a bunch of Macintosh draw commands, and then it will write them as opcodes to a buffer, which you can then save as a file in a resource fork, or just in memory where you can just replay those commands. Notoriously, it is just a pain to just rasterize by itself, because again, to support all these opcodes, you need to basically emulate all of the Macintosh graphics API. But luckily for us, we are emulating all of the Macintosh graphics API. So initially, like, we've managed to get like the introduction and other bits of the game working by using this PICT decoder, which is already part of ScumVM, which has already been used for like a number of other games, which implements kind of a reduced subset of commands. And that was fine for like all of the graphics resources, for instance. They mostly use like these pack bits and bits rect commands, which are just the equivalent of like doing a blit with a bunch of bitmap data. So that's all good. There was one picture in the introduction which used short line, which I added here. Essentially, because short line or the line drawing commands are kind of slow in macOS, it used that to do like a spooky kind of fade in effect with one particular screen. And so yeah, that entire screen was defined as a PICT that was full of short lines. So we added this bit in here which made like the graphics show up, but in order to get, we couldn't get the, what's it called? We couldn't get like the spooky fade in effect going, because this decoder is just rendering to an off-screen surface. It's not actually drawing live to the canvas. But yeah, okay. But then we managed to skate by with that for the introduction and a couple of the puzzles, but then we ran into this guy, the Polyominoes puzzle. I'll see if I can find one in the actual game. Mac 68K. Actually, yeah. Mac. Okay, we're just going to use MAME's Mac emulator because that's kind of the nicest one I've found for emulating System 6. I guess I could use Mini VMac, but it's so weird. I can't get my head around it. Also, the debugger in this is a lot nicer than anything else. Okay, so if we open up the game, the original game, the puzzle that we are trying to sort out, I think it's the Hermit? No, it's not the Hermit. The Hermit is a special one. Is it Judgment? No, Judgment was one that the reveal one. We sorted that one out last time. Was it the tower? No, I don't think it was the tower. I think the tower is a puzzle. Was it the devil? No, the devil's a different puzzle. Okay. Sorry for the guessing. I I literally can't remember. It's not Death. Death is another special one. Okay, Magician is another puzzle. Or another jigsaw, rather. The Lovers? Okay, no, the Lovers is a word search. It's got to be one of these. I don't think it's... No, it's not Justice. Justice is... Lights Out. High Priestess is something special. The Star? The Star, okay. So the Star is an example of a polyomino puzzle, which is that you have these kind of Tetris-looking, but more than 4 blocks puzzle pieces, and they have letters on them, and you got to, insert them into a grid, or, an outline, rather, so that they all fit. And that's all well and good. But this polyomino puzzle introduces a feature that we don't have yet, and that is essentially it uses the picture macro language. So you basically does like create pic. Oh, sorry, open picture. Yeah, so it opens pictures and then does a bunch of draw commands, namely setting the frame pattern, setting the pen pattern, drawing some polygons, and closing the picture again. We could, okay, so like, we technically could probably work around this by just doing that live, or modding the code in a bunch of places so that it did this live as opposed to replaying from a picture handle, but honestly, I don't think it's too big a deal. I think we can make our own version of the PICT API that just uses all the draw commands, because that's what it was designed to be originally. And that's kind of what we have here. So I've written a new version of Draw Picture that essentially reads from the... I don't know. Yeah, I changed a bunch of things. I changed the picture... Previously, the picture handle, we were just wrapping around that that other decoder. We don't do that anymore. Instead, we have a struct which just contains the bytes. And yeah, we essentially set up a brand new graphics port, completely perfectly untouched by anything. And then you use that... Oh, sorry. We copy over whatever bits, aka like the destination surface for the port. So that's still the same. And we change where... Well, we should... Yeah, we change where... Like what the port rect is, which defines the coordinate system in a way. So we got that. And then basically we just fetch an opcode and then try and do the Macintosh drawing API equivalent for that opcode. So most of them are just passed through for methods that we've already done. There are a handful which are not, or rather like all these color commands. This game doesn't have color in it. I'm not doing all of the color drawing stuff now. There's no point. I have nothing to test it on. That might come later. But not for Fool's Errand, mostly. Yeah, like drawing lines, drawing short lines, drawing text. All of the stuff is stuff that you can jam into a picture. But the one, I mean, honestly, like we don't need to implement any more opcodes than that. But we do need to implement these 4 opcodes, because these are the ones that are responsible for copying just bitmap bits from... Yeah, like what's meant to happen is that this fetches bits from the file, as in like, picture type bitmaps, and then converts it to the screen format. And yeah, I think there's like a normal... There's like, it can be either like unpacked, it can be packed with some kind of fancy run length encoding, and there's a third option where it can be using like a QuickTime codec. We're not touching number 3. Do not... Yeah. you can't make me. Not, you know, absolutely not something I'm going to worry about until color comes into the picture. But yeah, this other decoder that's already in ScumVM does support bits rect and pack bits rect. We've already had to like make a couple of little mods to that code to, like, for instance, the original one in the pitch decoder was not aligning properly because the original coder, for instance, like, it expects everything to be aligned to the words, so 2 bytes, because then apparently, like, I think that's like the optimum size for old Motorola 68K copyback stuff, which is understandable. Oh, also, yeah, the memory addressing in... I think it's basically because, like, memory addressing in general in Motorola 68K is on the word boundary, but don't quote me on that. I'm just making a guesstimate. Anyway, we did not have that before, and then that meant some images would just look all grody because they would lose sync partway through. But that doesn't happen anymore. Now, what we got to do is we got to kind of... actually, you know what? I am going to quickly save what I've got, because it does build, and we'll say WIP pict decoder. And we'll just have a quick poke around at, like, the previous working build for what we had, just to get a little taste for where we are. Full 2. Also, hey Mac, how's it going? Ah, that's right, I updated my packages, which means we get to wait for all the debug stuff to download. Is it going to be a few packages? Is it going to be a lot of packages? It's going to be a few packages. Unrecognized game Fool's Errand. Oh, because I didn't use my fool tree. I have a different tree that I do for director stuff because branch, I don't know. I don't like branch switching if I can avoid it. Okay, so here's where we got to. So the story basically works. There is still like a bit of a glitch here where it's meant to be showing like 2 of 2 and 1 of 2 for every story beat, not just, or at least every story beat which is multiple pages. Like if I go to the High Priestess, like you can see that's multiple pages, and it doesn't show page 1 of 2 or page 2 of 2. Got to figure out why that is. And yeah, we fixed the puzzle. So, oh sorry, the jigsaw mode. So we can jigsaw as much as we want. Let's see if I've still got the muscle memory after doing this puzzle like an ungodly number of times. Wait, no, it's here. Dang it, no. Where's the shadow? Oh, it's up there. Okay. Okay. There we go. Puzzle done. And then once you do a puzzle, it bounces you to a new part of the story which has just been unlocked. So in this case, it's bouncing me to the thief, which crashes because it is... Oh, interesting. Okay. It's crashing because there is an invalid rectangle. So I'll have to figure out what's going on there. Anyway, but yeah. So that's where we are. Now, check out engine full. And yeah, so the branch I've been working on has got quite a lot of changes. Actually, I might have fixed the... Oh no, that's a different problem with the rectangles. So yeah, I've gone ahead and not implemented all the polyomino puzzle, but at least the first, like the main function, which goes ahead and like caches all the images. And then there's like all of this brand new code for drawing like PICTs to the screen, which is close, but we need to go ahead and yeah, we need to go ahead and figure out how to port over the bits rect stuff, because it looks a bit weird, to be honest. I mean, honestly, like, all right, actually no, new plan. What I'm going to do is I'm going to... Oh, okay, I already defined struct RGB color. Yeah, let's just try and build it and see what errors come out. So I will probably... I mean, it'll definitely, like, die once it gets to those image drawing parts. So I should probably, like, put an abort or something in there. But then we can at least see, like, which... of like bits rect or unpacked bits it is, and then just save ourselves a bunch of time. Yeah, okay, I did already define RGB color. So okay. Missing initialize for member full region data. Oh yeah, okay, because yeah, alright, okay, fine. So that may cause problems, but we'll see. Okay. Yeah, as expected, everything that involves drawing a picture to the screen just freaks out, doesn't work. Oh, actually no, like just the entire method bails out because it cannot find the version of code. That's interesting. I was expecting it to screw up, but I was not expecting it to screw up like so early on in the piece, because I thought I copied that from the old decoder. Okay. So the version... What is that? 7401. That doesn't sound familiar. Because yeah, the version opcode that I thought we had. Okay, where did draw pick? So let's go my picture. Oh, okay, stream size. Okay, toolbox picked 128. Yeah, I should do. Okay, so it's trying to draw the first thing that I guess shows up, which would be the scroll. Oh, and I didn't turn the debug channel on, that'll be why. Debug flags, graphics, debug level 8. Okay. What? Picked items 128 offset 10. Okay, so the stream is empty. That's not ideal. Okay, so we're pumping air. Okay. So that would imply that the earlier code that I had for fetching the pictures, I suppose. Yeah, that didn't work. Sub 129.068. So maybe then I should put a break in get picture. See what's going on. Okay, so yeah, okay. So that okay, so it read that. Huh? What? Yeah, okay. It's because yeah. That should be, yeah, that should be a negative. I fixed this in one spot, but I did not fix it in the other. Okay. Okay, so b toolbox pict.cp, and we want it at 133. There we go. Okay, so now we can see all the gizzards. Yep. Okay. It's detected a version 2 type image. Or is it a version 1 type image? It's a version 1 type image. Okay. So yep. It's reading a single byte for the operator. Okay, then it goes straight to, okay, short comment. Short comment. Is that AO? Okay, I'm just gonna look at our technical manual here. Okay, A0 is short comment. That's fine. Don't know what the point of a short comment is, but we can ignore them. Okay, then we have opcode 1, which I think is origin. Might be origin. Actually, if you look at the other opcode list too. Oh, clip region. Okay, so it sets the clip region. Something that we need to implement eventually. I don't think the original code implements it, but we probably will have to at some point. Okay, and then opcode 98. Bits rect. Packed copy bits with clipped rectangle. Okay. So I think we should probably focus on that to begin with, and then work from there. So yeah, no point. Actually, I mean there is kind of a point. How about we go into here and then we go. Okay, so this will at least like not crash the engine, but we'll see what type of commands. Now, the rest of these, I think I might take out the ones for the, oh, what's it called? The stub for the comments, because they don't, they're just going to be noisy. Okay, and then we turn off the sloppy debugging so we can just see abort. Yep, okay. Alright, so both those times the image tried to hit pack bits rect. Now what I wanted to, what we should do is we should also check, I guess we should check the introduction. It'll be kind of boring watching the introduction without any of the images, but it will tell us a lot about do we need to support anything other than the other stuff. At least for now. Where is it? Up here. At some point I want to make it so that the introduction is accessible through the drop-down menu, but that can probably wait until the game is mostly working. So clip is probably a good thing to support because that's just going to be setting something on the something on the graphics port, and yeah. And our friend pack bits rect, because that's used for most of the introduction, it would seem. Huh. I was hoping we'd at least see the spooky fade in text, because we do implement like the line drawing command, but maybe there's something we're missing there. Okay, yeah. It's all It's all bits rect. So let's focus our efforts on that. So if we look at the original PIC decoder, we have this unpack bits rect command on pack bits rect. That in turn calls unpack bits rect or region with these flags. I think, yeah, we just need. I reckon we could just merge this into one function. So just say read pack we'll change the return type later. It's okay. Yeah, I don't get. Like, it does this little introspecty thing here, but I think we should probably just take whatever this manual says as a sign of what we should be doing. So pack bits rect. See listing A2 on page A17. Okay, so we fetch a PICS map, potentially a color table, source rect, destination rect, transfer mode, and the data. Okay, so let's create another little basic thing here. I think there is some code here to read a PICS map. So, yeah, let's copy this. Now, like the robytes stuff, I'm not so sure. Robytes. Okay, I'm gonna read. Okay, screen itself is one line. Bit image. The row bytes field of the bitmap contains the width of a row of image in bytes. A bitmap must always begin on a word boundary and contain an integral number of words. In each row, the value of the row bytes field must be less than hex 4000. Bounds field is a bitmap boundary rectangle, which serves two purposes. First, it links to the local coordinate system. Second, defines the area. Okay. So it's like. Ah, right, okay. There's like PICS map and then there's bitmap. And I think that, like... I think that the original PIC decoder tries to do... tries to overload PICsmap to also work for bitmap. We are not going to do that. We are going to have different types. Because, yeah, if we look up PICsmap... yeah, okay. The PICsmap record for your web window there contains the correct pixel specifications for the main screen, color quick draw. Yeah, okay, so index colors uses PICsmaps. I'm pretty sure... oh, there we go, okay. A bitmap is defined by a data structure type bitmap, and it represents the positions and states of a corresponding set of pixels, which can either be black or white, or the 8 predefined colors provided by basic bitch quick draw. A bitmap is contained within basic graphics support. A pixel map is defined by a data structure of type pixmap, and it represents the positions and states of a corresponding set of color pixels. A handle to a pixel map is contained within a color graphics port. Okay, well, we don't have to deal with pixmaps, I'm pretty sure, for monochrome imagery. So that's what I think this like has robytes dingus is doing. It's just trying to overload that. We don't need to do that. That's too much effort. Did I define bitmap as a type? Oh, I did. I defined it as common shape pointed graphics managed surface. Great. Which is sort of true. Like, I want internally in like the game engine, you do pass these around a lot, and it makes more sense to have like the native format. So I suppose we're gonna have to go into here. So is PICsmap used anywhere else? No, I just preemptively took this. Okay, so get rid of that for now, because we're not gonna use it or test it. That can go in here. I think it will make sense to go. Okay, so now we can define the much simpler where's this? Okay, where's the... okay. Bitmap records. There we go. So the bitmap record is like 3 fields. There we go. does it even really help us for like decoding it? We'd still need to. You know what? I reckon we could just do it in line. Doesn't matter if it's a little messy. That's something I can live with. So we'll just go read. I see. Okay, so we have that struct. Okay, so it's got like has base address is if there's no palette, and then it has row bytes is this. Okay, so yep. That's like, I mean, what about all this junk? Because it's not going to be a pix map, it's going to be a bitmap, isn't it? Or is it always a, pack bits rect. Packed copy bits with clipped rectangle. Okay, so apparently it's always a pix map. Pictures created with the open picture function in a basic graphics port use the opcodes of the version 1 format as listed in table AE. Does size of fully opcode. Huh, alright. I guess we do need pix map. Because your application can typically deal with graphics port instead of hardware devices. No, I want the, where's the record? Pixmap rec. Here we go, okay. Here, okay, here it freaking is. Okay, the offset device from one row to the next, the value must be even less than 4,000, and for best performance it should be a multiple 4. The high 2 bits of row bytes are used as flags. If the bit 15 equals 1, then the data structure pointer was a PICTs record, otherwise it is a bitmap record. That is evil. I'm sorry, I hate that. That's... Yeah, that sucks. Okay. So that's... I was like looking at this and thinking like, okay, there must be like some kind of... there must be some kind of type trickery using here so that like there's backwards compatibility. I just didn't know what it was, and this is probably it. Oh, great. Okay. So what I'm thinking is we should change our version of readPixMap so that it has a little field in here. It goes so a new little private bit of information. So then we the base address field of the PICTs record for an off-screen graphics world contains a handle instead of a pointer. You must use get_PICTs base address function to obtain a pointer to the PICTs record. Your application should never address the base address field of the PICTs record for an off-screen graphics. You should always use get_PICTs base address. Okay. That's fine. Okay, my hunch is that we should always be reading the base address. PICTs map base address equals stream read int 32be. And I also read robots. And then PICTs map is bitmap. Bounds, we go if PICTs map is bitmap. Then we load all this other crap. I think that sorts us out. Yeah, like my understanding is that this is always going to be there, but because I don't know, the decoding is kind of split in this original one here, sometimes it's not all there. Okay, but that's fine. Okay, so we got our PICTs map. So I just go PICTs map. So we read that from the stream. Right, and then we've got... Yeah, because it's checking to see if it's got a PICTs map before it does all this. Okay, so this is not going to have a PICTs map. So then it just goes straight to unpack bits, which is going to be yes on the compression front. Because, yeah, we've got like pack bits rect, which compressed is true. Okay, so we unpack bits with compressed is true. and region false. Yeah, the other kind of worrying thing is it says it should be possible to merge, like there are two decoders, and it says this one should be possible to merge with unpacked bits rec, but that's a story for another day because this works for now. And this here, it does use, yeah, it does use 1-bit unpacking. Where if we compare this to unpacked bits rect, yeah, okay, okay, that uses like at least 1 byte per pixel, so I think it's probably proper to have a different decode pattern for that. So we'll say if pixmap is bitmap, read pack bits rect. Okay. Okay, so, oh, and we should probably pass in. Yeah, I'm not sure how we're gonna untangle this so that it. But like, ideally, I want the output of this to be a surface, like a graphic surface, so that then inside the decoder we can run this command to get the data from the stream, and then shunt it through copy bits, which presumably would be what the deal is. Okay, all right, back to borrowing from this. We know this is going to be a 8-bit decoder or a 1-bit decoder, so let's just slap this all in here. We know there's not going to be a region. I mean, if there is, you know, if we do encounter images with regions, we're going to have to find out exactly like how they're meant to be used. It's not good enough to just read this and ignore it. Ah, right. Okay, and then now we have right. Okay, so this would be like our first big departure from how the original is going to work. The original decoder is drawing relative to the full output surface. We're not doing that. We are we are drawing absolute to whatever region is set. So I'm guessing the bounds region. So I'm going to say, so we'll get rid of the output rect. So if we just go compressed, okay, so we're gonna go graphics, managed surface results, result, and that's gonna be bounds width, bound height, bounds so as per all the other actually, yeah, let me check the other drawing code that we have, because I'm pretty sure that we've standardized on an 8-bit surface with like 2 colors in it. Yeah, alright, so we have I see, okay, so what does this get called? Huh, okay. Do we not call create remapped surface? That I find difficult to believe because, hang on, how do we convert it then? Because part of the issue, or right, the reason why we have to have like stuff like this is that there's a mismatch between, okay, so like in Macintosh, or like in the Old Testament Macintosh like this, there are 2 colors. There is color 0, which is white, and color 1, which is black. But that's not how I guess the ScumVM window manager code works. I think it's something like black is 0 and white is 4. So this method here is specifically for converting between the, I mean, like the rest of the game just deals in mono, so these two colors, but the window manager has to convert back to like color black and color white, which is all the stuff down here. Hey, Wormsoft. Yeah, we've gotten to the point where in order to simulate this puzzle, we need to implement PICT, which is like the opcode based drawing format. Because like, yeah, essentially the Macintosh API allows you to just do a bunch of draw commands to quick draw, but you can direct it to like a memory stream as opcodes instead of as, you know, bits, because that takes up memory. And because this particular puzzle relies on that, so each of these puzzle blocks is stored in memory as like one command which draws a polygon, one command which draws some letters, and then in order to move it around, it just draws the picture at a different spot each time. So in order to do that, we are trying to implement like as much as we can of the PICT format. But yeah, where we're getting hung up now is that originally we were using like there's already PICT code in ScumVM, which has a subset of the commands we want, but that isn't really useful for us because yeah, this all renders to a surface as opposed to, you know, runs draw commands in our drawing pipeline. Wormsoft says, "What's the name of this puzzle? Totally not Tetris." I don't know what the real. I don't know what the name per se is. It's just a type, like one of the puzzle archetypes in this game. The description here is place all the pieces together so they fit inside the black rectangle. One piece is already in its correct position and cannot be moved. To move a piece, use the mouse to click and drag that piece to a new position. So, and like the idea is that you're meant to arrange these so that they fit, and you also get like a word as part of that. So I've just been calling it polyomino because that's what these shapes technically are. They're not tetrominoes because there's not four squares, but they kind of look like Tetris pieces. So annoyingly, we have to kind of get this bitmap code in so that we don't have a massive regression, because so far, like everything else in the game, well, large amounts of the rest of the game rely on drawing bitmaps. So we've just puzzled our way through like figuring out how they dealt with backwards compatibility between monochrome graphics and color graphics, and the answer is the second field can have like yeah, if bit 15 equals 1, then the data structure is pointed to a PICT map record, otherwise it is a bitmap record, which is pretty evil. It's not the most evil thing I've seen, but and yeah, we should do that properly then. So it's C, I think. Or rather, oh, no, sorry, it's still 8, but the value must be even less than 4 hex 4000 for best performance. It should be multiple 4. Okay. Wormsoft says, I'm creating my own IDE using a very old UE library called TurboVision. It is amazing seeing that old considerations for old machines with monochromatic displays. That's pretty cool. Is that that's by Borland, right? Is that targeting like the monochrome adapter or EGA high res, or what kind of graphics mode does it use? I'm curious. Anyway, okay, so we've got all that. We just need to go down here. So we need to make a few incisions. Namely, we need to go into here and change output surface to results. Results. Also, we should go wherever stuff says it's complicated. It is intended to run on terminals, like any terminal. Windows, Linux, or even MS-DOS. Oh, okay, so it's like a text mode API. Like, similar to ncursors. Does it actually run under Linux? Did they port it? Did someone port it to termcap? That's pretty neat. Okay, so now we need to sort out what's going on here. So we've got bounds. The boundary rectangle, which links the local coordinate system of graphics port to QuickDraw's global coordinate system. By default, the boundary rectangle is the entire main screen. Do not use the value of this field to determine the size of the screen. Instead, use the value of the GDREC field of the GDevice record. Okay, well, we're not using it for the screen. What I want to know is, can we use it for figuring out this? Actually, no, wait. I'm in the wrong spot. I should be going down to A17. Okay, so we've got a source rectangle, we've got a destination rectangle, we've got a mode. And we've got a PICTs data. Alright, my guess is that then the PICTs map bounding box is meant to be the go. Oh right, but okay, no, so that's already not right because we've already got the bounds. So it should be oh, easy. Okay, then we just need to remove this. Okay, So where are we? Okay, so that returns a managed surface, which right, okay, and then now it kind of comes down to this has got to return a shared pointer. Where stuff says tries to adapt to the colors the terminal has. So you say get color and it gives you the closest color you want for the terminal you're in. Oh, neat. It's yeah, that's a little difficult to bridge. Because yeah, you got, especially in Linux where you've got like the bog standard 16 color terminal palette. Is it? Yeah, 16 colors. Then you've got like the Xterm 256 color extension. Then you've got ANSI escape codes, which let you just do 24-bit color. Then you have like weird escape codes which allow you to just draw random bitmaps in the terminal, which, yeah. I don't know. Like I have, yeah. I mean, I've written a Python library which uses like the 24-bit codes and half-height characters to draw pixel imagery to the terminal. So see if this still works. I have not tested this for a while. From work import here. There we go. So here's some random sections of graphics from Lemmings, but yeah, that's all done with. There is like one box drawing character which is 2 squares stacked on top of each other, and let's combine that with the foreground and background ANSI drawing codes. Yeah, this is fun. Drawing in the terminal is fun. Unlike this, which is a little annoying. Okay, I'm going to change my mind about what type this is going to be. This is now going to be return a bitmap. And we're going to go bitmap results, new graphics managed surface. So all that is just a shared pointer that wraps it, so it's reference counted, and I don't have to worry about ownership. Oh, okay, it built. So I didn't put a thing for read patpix rect. Oh, Wormstuff says, Wormstuff says, look at that beautiful game art. Yeah, I really like the graphics in Lemmings. It's peak. Just peak. Microsoft also says, I made a render library that allows you to provide the draw pixel function, and you can create games with it, like in MS-DOS mode 13H. Oh, neat. So, does that... Actually, I don't know. It would all depend on like how the graphics library does it in the background, but like, I assume it would change the position of the cursor on the current screen and then just modify that one character. Oh, Whereversoft says, yeah, if you provide a draw pixel function that draws in the terminal, your game runs in the terminal. Yeah, there is... I think there's like AAlib, which does something very similar. It just kind of like provides an output driver which uses ANSI, and I think like SDL and other libraries can use AAlib as a backing source. Maybe I'm misremembering. Maybe AAlib is different. It was it was a while ago, but anyway, okay. So we've got the bits. Okay. No, I've already screwed up. Okay, so we need the pix map, I think, to... Oh, actually, no, there's more outputs. There's more outputs than just this. Because we need the source rectangle and the destination rectangle. So it's all well and good that we've got the surface. I think we just have to go like... go like this, and then do it all in here. Source rect and dest rect used? It's not. Okay, so that's something we probably can do outside of read bits rect mono. Transfer mode may include new transfer mode. Okay, that's fine. Okay, so this just fetches the bits. Okay, this is now going to become void again. I've changed my mind. Now we're going to do the copy bits command. Copy graphics. Oh, sorry, copy bits. Results. Oh, bollocks. Okay, no, we can't do that because it's going to be in... Because we need to provide the graphics port. So we're going to have to go toolbox, draw pack bits rect. Port bits. mode. Null pointer. Yeah, that makes sense, I think. Okay, so we can now go here to the internal events of shame and add our new okay. Good enough. Oh, source rec was not defined in that scope. Yeah, fine. Okay. Maybe I wasn't thinking. You know what? All three of these. Let's... Okay. Let's see if anything shows up in the introduction. I am skeptical that it will. Yeah, okay. We got big problems. Draw pack pixel pixel map. Oh, come on. Come on, don't do this. Alright, what's the deal? Why are you trying to pretend that there's okay, so okay, so we have row bytes, which is a tiny ass number, and we have is bitmap, which should be false. Yeah, okay, good. Oh, okay. I once again got true and false mixed up. Which is a real feat. Okay, well, good. At least it's not crashing. At least the guardrails mostly work. Yeah, until that. Width minus 281. Okay, great. 9. So we've got a rectangle. They just appear to be not read in the right order. Did I seriously screw up redirect? Yeah, top, left, bottom, right. I mean, is it a... I thought that was the right order. Is it all reversed? Okay, notice that while a rect record lists the fields for rectangle boundaries in the order top, left, bottom, and right, you pass these boundaries as parameters of the set rect precision in the order left, top, right, and bottom. Okay. And like the original PICT decoder, which I'm pretty sure I fixed. You want to tell me what order that's meant to be in? Yeah, it's top, left, bottom, right, which is what I thought it would be. So it could be that maybe the offset is wrong, or that I'm like reading nonsense. Debug level 8, debug level debug flags graphics. That should give us the dump of what's coming through the pipes. Okay, so here is our image. Yeah, okay, so it's off by 2 bytes is my takeaway. Because this looks like a sensible rectangle. That is just whatever came next. This looks like a sensible rectangle. This looks like a sensible rectangle. This looks like something that got cut off. Was it this? So maybe it was row bytes. Either base address or row bytes, which got cooked. There's like a flowchart and a there's like a flowchart version and a Pascal version. I want the Pascal version because it actually gives you the types. It's gonna be somewhere in here. Bitmap record. Okay, this is it. So that's like type pixmac record, which is like pointer, integer, then rect. C graph port. Actually go data structures. Okay, data structures. Bitmap data struct. Yeah, okay, so it's a uint32 followed by a word followed by a bounding box, which is what it should be. Why? Which part of that is screwing up? Oh, read pixmap. Yeah, it's happening in the right order. It's absolutely happening in the right order. So what's... let's just add a couple more hinty things. So we got... Okay. All right. Come on. We got this. We got this. Start. Okay, so we've drawn a picture. It's, or sorry, we've got to the draw pack bits opcode. It's pulled. If we look at like the exact contents of the data. Actually, sorry, where's the offset? The offset is at D. Which would be here, I think. Yeah, okay, so 98 is the opcode, and then we have this random memory address that got saved. And then we got the row bytes, and then we have this rectangle information, which looks reversed. What the hell? What the hell? Oh, but wait. What if there's no row bytes? I mean, okay, to my mind, it looks like that we got row bytes followed by one rectangle followed by another rectangle followed by a third rectangle followed by a mode followed by just pixel data. Okay, so then, like, what I'm taking away from this is that maybe... okay, so that was the other bit of this which I kind of glossed over, which is, how does it know that there is no... no base address? So if there's a base address... So there's a base address... If there's no palette... What? Okay. I mean, in this case, clearly there's no base address. I just need to figure out, like, why we know this. Unpack bits. Correct. Okay, so I see. Okay, so it's only if it's a paletted image that it has the base address. So we can go back and modify this. Yeah, I think the default for this is that there's no base address. Yeah, okay, we want to park it here at 204. Okay. Do we have a picture? Do we... Oh. Oh, I just... Yeah, okay. I added... I added a new parameter, but I didn't think, hey, maybe I should set that to something. Okay, what do we got? All right. Those rectangles look a lot better. Notably, top is less than bottom and left is less than right. So maybe if I were to do this and do read bits rect mono, okay, it then just, okay, did not like that. what was it trying to set? Okay, it was trying to set... So we got this PICTs map which goes from like 72 to what's called 72 to 110. Okay, and I see what the issue is now. So we need to adjust this so it is now PICTs map bounds left. So this is now surface centric. Okay, that becomes 0. Hey, Eljo Joker 4. They ask, why not using Pwn GDB instead of GDB for better view? Just down to just down to muscle memory, I guess. I've tried a couple of I tried CGDB, did not get on. Like it just doesn't work for me. Okay, well it got further that time before it crashed, which is good. Okay, it's still out of range though, so is this using up 9? Okay, so this is using the unpacked or the uncompressed version of this. Wait, no, this is the uncompressed version. This is the compressed version. Okay, so where did it go wrong? How did it overflow the bounds? Ypos bounds PICTs map. Okay, so the bounds. I see. Okay, so the top, I guess, is slightly out of bounds. Why is Ypos 0? Why are we starting from there? Oh, okay, no, because the surface coordinates. That's right. That's what we're doing. Yeah, so we got top, left, bottom, right. So then that would mean the X position is wrong. Yeah, okay. So I imagine then that results get bounds. Okay, so it's like a 40 by 520 surface. Alright, so how does this decoder work then? Looks like all these previous graphics decoded without too much stress. This last one does have stress. Yeah, right. Okay, so the bounds must be the bounds must be the graphics data. Okay, so it's using some kind of run length encoding thing where it's, you know, runs of the same black or white color are stored as just length prefixed values, which makes sense. But I mean, like, where are we? We must be like past the end of the surface for that to happen. Okay, yeah. Okay, for now we'll just do a check. If x plus is greater than greater than or equal to, now let's get with break sorry, pix map bounds get width. It's gonna look buggy. I'm resigned to that, but for now, buggy is better than crashing. We're gonna see something. Actually, no, we're gonna see a whole lot of nothing. That's fine. I can live with that. All right. But it did decode those images. Next question, why nothing on screen? Why is that not being drawn? Yeah, okay, so I had I mean, could it be that we're not? No. I was worried, like, are we not setting the dirty rectangles? But if that were the case, then hang on a second. Look at this. It's like a little tiny strip of the mountain in the background there. Not only like a little, wait a second. Not only is a little tiny strip of the mountain, it's using a forbidden color. It's using gray. We don't recognize gray. Where is gray coming from? What is what is this? How do we learn about this forbidden color gray? That's what's going on? I think, okay. So to narrow this down, we're gonna have to go back into here. We're going to put, where is that copy bits? This guy here. There must be something going skew if in here. I'll also do results debug print raw surface debug print there it is. Okay, I want to see what's in those bits. Toolbox picked, let's see, 215. So now just before we draw something to the screen, we can have a look on the terminal and see what's actually in the bitmap. Okay, well, that looks... Yeah, okay, so we're decoding the image properly. And that does appear to be, yeah, okay, and I think that that's the correct way around. Yeah, okay, so that's got like white as FF and yeah, so sorry, white is palette 0 and black is palette 1. And the debug print command I think tries to round that to the nearest terminal index. So yeah, okay. So we've got the right ingredients going into this cake. We just don't have a tasty meal. We just have nothing. We just have a void. So tell me more about what is going on in... Right, okay, and the part of why that is going to be a problem is because of source-rect, because source-rect is in terms of whatever the bounding rectangle of the PICTs map is, and we haven't normalized it. So that is going to be pointing to an area that's outside of the logo, which then blit to the screen as nothing. Okay. I think we're onto this. Okay, so yeah, we've got this bounds rectangle. We need to convert these source rectangle coordinates to be in, like, you can see that there's like a big bar down the side, 6 pixels wide, which would line up with this rectangle thing here. So I guess we got to chop that out. We can do that. We can do that. So we'll have to go. All right, but now like the destination, I think we can get away with it by just moving them around. If we're careful. So the source rect, so we'll just go, we'll just do it the messy way. What am I saying? We don't even have to do it the messy way. We can just do source rect move to. Oh, okay, that's okay. Okay, so we go source rect move to pix map bounds left, or just move, I think. Contains height group, move to origin, translate, that's it. Okay. So that should, okay, that should now be in pixmap coordinates. Destination, I think we just keep destination as it is. It may mean that like stuff renders on the screen in the wrong spot, but okay, so I'll just let it run. Okay. Oh, again, look at this. Like, it's using a... Where is it getting gray? Where is gray coming from? You shouldn't know about gray. I mean, this looks cool, but you should know about gray. Oh, no. Oh. Okay, and there's also a bug in, like, the line drawing code. But, yeah, This isn't ideal. This isn't what I wanted. I don't know how it's I don't know how it's like misinterpreting all this. Oh, Magician Sardog says the Fool's Errand enhanced. I mean, back when Cliff's website was up, he had not photos, but like screenshots of a 256 color enhanced version of Fool's Errand that never got made. Or I think like they prototyped a bunch of the art, but they never got anyone interested in making a CD-ROM edition. So, you know, that could be, you know, that could be restored, but like, what is going? Okay. Well, we know that these pictures are being decoded correctly, but we don't know where. Like, okay, how are we getting the color gray? Because we're just using copy bits, and copy bits. If we look at like the wording of copy bits, I'm pretty sure I send it through the yeah, I send it through here, which does a bunch of clipping stuff. Magician Sodonic says it's not like the background or the foreground color selection. No, it should be. Like, there's only one. Oh, that's cool. The game works by having several screen-sized monochrome buffers, and I guess like in the case of like to do like the raindrops, that's just drawing to the screen, and like it draws with the exclusive OR tool. So basically, like one frame it'll draw a line, and the next frame will undraw that same line. So that's I get it. I don't understand. Because yeah, then like the actual blip to the screen using the graphics mode is this blip mono function, which should, yeah, okay, so like it does like the translate and everything, but create remapped. Yeah. Right. Okay. So the oh. Okay. So I think that what this was. So let's rewind to one commit ago when everything was working. Remapped. I was wondering like, why is that not referenced anywhere? It was referenced somewhere. It was referenced in Draw Picture, which was the original. So the original code that I had would yeah, it would use the ScumVM default pict renderer. It would render it to a buffer, and then it would convert it to a mapped surface, and then shunt it through copy bits. But I didn't. Okay, so we just need to add this step back in, and I think we're good. Yeah, okay, that makes sense. So those stuff that goes through, gets sent through copy bits, has to be in screen. Has to be converted for like the screen palette, which is a departure from how, I guess, a departure from how like macOS works, but then it just saves time having the stuff pre-converted. Okay, so then So back in here. Okay, and then wait, what did I do? Oh, because the palette came from the picture. Sure. Okay. So okay. So we can just we don't have to provide a palette. Thank God. Okay, so we can just go back into here and go null pointer 0. Okay, that explains how it found out about gray, because I'm pretty sure gray is 1. Well, sorry, yeah, that's right. Okay, so in the default palette used by the Macintosh Window Manager code in ScumVM, white is 0, and I'm pretty sure gray is 1, and then black is like the number 4. So figures that everything would be all kind of cooked like that. So if we reload this, I think this will mean that the graphics will show up as monochrome. They'll just appear in the wrong place because we haven't got the like the alignment properly working yet. Yeah, okay, so the logo is a little bit off. These are just in completely the wrong spot. That could be argued to be in the wrong spot. Interestingly, the weird overlay doesn't work. Okay, yeah, that's in the wrong spot. This looks cool as hell, but it is in the wrong spot, and it is not it's not correct. Oh, weirdly enough, this, which I think is just like, I think it's working because this is a full screen bitmap, and so there is no offset for it to screw up. Yeah. Okay. Cool. All right. Now we just got to find out where what we got to do with the Okay, first though, there are a couple of things I didn't like about Okay, so think, okay, so let's put a breakpoint here at just before copy bits, and then figure out like how we're meant to be offsetting this destination rectangle, because we're not doing it right. Possibly because I'm guessing because we're meant to take into account where the bounding box in the graphics port is, and we don't do that at the moment. So B toolbox pict.cpp221. Okay, so very first cab off the rank. What do we got in the... What do we got in here? Ah, alright, I've already realized something I was meant to do that I did not do. And that is... here, where we create a temporary graphics port. So that should, I think that should initialize everything properly. Okay, but then like the second thing is that, yeah, so it sets this port rectangle, which is meant to kind of constrain where on the screen everything is being drawn. And yet we have this bounding box here. And that kind of makes me think, I mean, what do we have? We've got like 116 to 391 versus like 1110 to, oh wait a second, 79 to 394, 354. I guess the other option is we can eyeball it from okay, so what about this one? So this picture here goes from, okay, it takes up like a large slice of the screen. So 0 to 512, and then 70 to 200, and then the rectangle on the screen, okay, it starts at 150. So 150, so it's 130 pixels high, yeah, okay. Okay, so my reading of this is that we should be like we have these bounds. We can subtract that to get like the offset in bitmap space, and then to get the position in destination space, we would have to add the top left of the port rect, I think. I think that's right. Whatever, let's see what happens by doing that. We're gonna have to do this for like pretty much every drawing operation as well, because that's probably going to contribute to some of the glitching. There we go. All right, that seems to have sorted that out. Okay, that looks a little sickly. That's off by like a few pixels, upsettingly. That's just no longer on the screen anymore. Okay. This is drawing with the right color now, but the coordinates are all kind of messed up in a cooked way. Okay, this image looks fine because it is full screen and I guess isn't offset by a weird amount. Oddly, this looks okay. That also looks okay. Okay, so we get in there. The math is close. But okay. Dest rect. I forgot about the pen, didn't I? Because draw picture, like if we look at the draw picture command, we shouldn't be doing it in terms of the canvas preset necessarily. We should be doing it in terms of the pen. Oh, no, the frame. Okay, no, this does, I see, all right, no, that does it does not draw it relative to the graphics pen. Okay, in addition to taking a handle to picture viewer as one parameter, draw a picture also expects a destination rectangle as another parameter. You should specify this destination rectangle in coordinates local to the current graphics port. Oh, okay. I think we just set this on the port. Yeah, so we take destrect and yeah, we just stick that in port rect. Okay, so yeah, in that case the top left is the origin. So we should be translating the coordinates relative to that. That makes sense. Source rect needs to be in bitmap coordinates. This rect needs to be I mean, it could be argued that copy bits itself needs to be bumped rather than. Yeah, actually, I'm kind of that mind. Okay, so. Yeah, so we got the source rectangle and then we got the destination rectangle. And then okay, yeah, and then it uses clip dest rect and everything to figure that out. Okay, destination rectangle should be transformed. Should to port origin. So clip dist rect translate port rect left, port rect top. Okay, is that right? Okay, so like if we've got the origin is set to 100 pixels in. No. Also expects a destination rectangle as another parameter. Should specify this destination. Okay. Tell me about copy bits. Copy a portion of a bitmap or pixel map from one graphics port into another graphics port. Okay, using the source rect and dest rect parameters, you can specify identically or different source or destination. Yeah, okay, that's fine. Like, I understand all that. What I don't understand is like dest rect. Let's say, when you specify rectangles in the source rect and destination rect panels, use the local coordinate systems of, respectively, the source and destination graphics ports. Okay. So, yeah, I imagine then that you'd have to add this. So if the format, because yeah, the source rectangle is going to be like in surface coordinates and the destination rectangle should be in graphics port relative coordinates, according to my reading of that, which would then mean that we'd also need to make this pixmap bounds left into max bound. Okay, it's either that or maybe like, maybe this needs no translation at all. We'll run it again. If it's still glitching, I may comment out this line and see if that helps. Okay, this logo appears in the right spot. But these are all a bit herky-jerky. And then this screen is just completely busted. Okay, so if I were to remove that transformation, would it be any different? It would. No, okay. I mean, things much worse. Okay, well, we sort of have the right idea. I want to know what the deal is with this surface here, or rather, like the skull surface, because that. Yeah, and it looks okay, and I must have something completely cooked with those line drawing coordinates. Okay, okay. Okay, new plan. We're going to investigate each of these in turn and then see which image is being loaded. So that should give us more insight as to like how much we're off by. So 223. V4 toolbox pict.cvp223. Start. Okay, so we got this logo. We know it. We love it. It looks like it's pretty much in the right spot. Okay, then we got the shot of the mountain. That also, to my mind, was basically in the right spot. Then we have this grab of... You know, I'm just going to skip straight ahead until we get to the head of the High Priestess, because that is off by a lot. And that should be very visible. Ah, interesting. So I guess the head of the High Priestess is stored in strips. Or rather, like, the picture opcode stores it in strips. And yet... I see. Okay, so it's drawing it seemingly in the same spot over and over again. Oh, no, sorry. The y coordinate is increasing. I'm just not paying attention. Okay, but we have this. Okay, and the port rectangle is like 00342. It's like it's full screen. So I don't get why. I don't get why this is rendering properly. Huh, oh wait, okay. No, that's a problem. So this slice of the image... Yeah, okay, so it's... Yeah. I see what we're doing wrong. Okay, so subtracting the bounds from the source rectangle, perfect idea. No troubles whatsoever. The destination rectangle, however, that is not relative to this. That is relative to... that's relative to... Well, okay, it's relative to the graphics port, it would appear. Yeah, it must be relative to the graphics port, so... Alright, but then like the trouble then becomes, how do you, well, if it's, I mean, then how is this also wrong then? Okay, well, so from my read of this, we shouldn't be messing with the destination rect. But if we do that, then everything looks like certifiably worse. So which is it? Why is it meant to be worse? Yes, it's using the coordinate system of the graphics port, which in this particular case has been modified. to be the output area. What is, okay, what am I missing? I'm missing something, I just don't know what it is. Packed pits rect. Create remapped surface. Yeah, okay. Destination rect should be unchanged. We've got to trust in the process. We've got to trust in, at the end of the day, this is designed to be shipped into copy bits. So there must be something that we are messing up in our copy bits calculation, which does not take into account. Yeah, so where are we doing this? We are doing this in picked, repick smart, rebits. Ah, right, okay, so it's in 223. Okay, Fool's Errand. Let's look at these outputs closely. Okay, so C port rect. So the port rect is it's kind of weird actually. 170 by 116. So it's 170 to 254, and then we've got 110 to 194. So that, okay, but then that feels like it would be out of bounds. Okay, so it's 275 by 84 picked, and we want to draw how much? 275 by 84, so exactly the same. So what I do not get. Right, and then we look at the PICTs record, and that has bounds of 110 by 72, 194, 360. Okay, so maybe the bounds is actually, because yeah, we have to, so like, yeah, the way that you kind of have to imagine it is you have to imagine like an infinite plane with a little rectangle that's cut out of it. And you're going to say, all right, we're going to draw the PICTs map into this little chunk of that infinite plane. And then you got this source and destination subset of that little rectangle. Okay, so I guess the destination rectangle is affected by bounds because it is just being positioned like that. Okay, let's try that. Well, I mean, that's what we had here. That's what this was. Okay, I'm reconvinced that everything is relative to that, but then I guess that just kind of that doesn't explain why those high priestess image slices, like how they're meant to work. Screw it. Okay. Like that made sense, except like the PICTs map then moved around. Oops. Okay. Oh, I gotta stop printing the hex dump. It's no longer useful. Okay, so we've got right. Okay, so we have the background image, which was this High Priestess skull, and then we have the smaller overlay, which is the High Priestess's human face. But now we got to figure out what's going on with these bounds. So the bounding rectangle does move. Okay, but then so then that must be still in. That must be still graphics port coordinates. I don't know, but yeah, you know what, we've hit 3 hours. I'm gonna take a break. I'm gonna take a snack and tea refill break, I feel. But I mean, we're so close. It's like the Mr. Policeman, I gave you all the clues level of close.
Sandwiched together there. Yeah.
Those snack size like items frying up in a hurry. And now
Yep, I got cold pizza in the fridge. I'm gonna get some of that. Oh yeah, the other option which we could look into, would be double checking what the original decoder does. I mean, we did just, yeah, okay, because the original decoder does have an offset, which we removed. Maybe if we just kind of like very carefully check what that's supposed to be. Yeah, so in here, like we have, okay, so we've got like a bounce check, which is important. But we have like expose. Yeah, okay, so this image rect, which I think was like the, yeah, okay, so that's all done against the image rect. Anyway, time for that in a little bit, but yeah, I'll be back in about 5 to 10 minutes.
Oh, Strongman, the peoples want to know, what's the secret to your pizzazz?
Darling.
Yeah.
How's space?
Yes, very pretty.
I'm her date.
Good one, man.
Kids see what comes out when a cokehead blows its nose.
How funny is that?
Often on a napkin from a knob's restaurant.
That man is lying on his back thinking, where in shitting crikey is my nose? It's in a jar, mate.
I feel
Okay, taken from that right there. Yes, go ahead.
Yeah, here in this.
When Taylor and I left him at his house, he was healthy.
You're a real desperado.
Maybe everyone doesn't aspire to your level of criminal mind.
Oh.
It's time for a little trickery of our own, Robin.
Imagine that is at 11 o'clock. And this week, the businessmen are trying to imagine the two Ronnies having sex with each other.
Don't be silly, John. Don't be silly, John. It's a first aid box.
Okay, that's enough of that. Okay, I think I found what we're missing. So, at the very start of the PICT format, there is a rectangle called pick frame, and that's it's referred to here as image rect. But then when we look at the decoder, which is the thing that we ported, it offsets everything in terms of pick frame. Oh, sorry, to image rect. Yeah, here we go. So here is our 1-bit image decoder. Okay, and then it shifts everything in terms of that. So I guess we'd have to pass it in, I suppose. I guess we'd do that. Like, we check to see that, like, the destination rect is the same dimensions as pick frame and pick frame height. But we don't really, we don't do anything in draw picture with that, which is something that we should change. Let's go back to up here.
On the day-to-day tonight, MP in heartless outburst after bomb goes off in Hurd's bath.
Well, one bomb's going off in the Foreign Secretary's hand, but all he does is say, well, I didn't need that hand anyway.
And a warm handshake from Michael Heseltine for the children he is about to release into the woods and shoot.
How do you do? Nice to say hello to you.
Yeah, okay, so that's there. So that does a check against output rect. Maybe we should just do that. And then we can just literally do what we were doing before. Smashing. All right. So that's sorted. Now I guess this just needs... Okay. Oh, Mad Moose says that was a long one. Yes. The randomizer tries to split based on the end of sentences, and I think that like the news reads at the start there do not have they do not have like terminating punctuation. They just have like capital letters or whatever. Okay. How bad could it be? Well, it's a... Yeah, alright. Not ideal. That's how I would put it. Yeah, okay, and that's in completely the wrong spot. That's also in completely the wrong spot. That's still wonderfully not correct. Hang on. Okay, let's have a look at these. Ah, interesting. Okay, so that appears to have we're now getting clipping errors with actually like getting the graphics out. That's unfortunate. But that implies that they're in the right spot. They're just not being decoded properly. So, yeah, okay, so coming back to this pick frame nonsense here. I mean, to my eyes, the result bitmap looked fine without taking that as an argument. Picture frame only, yeah, okay. So what if we walk back this change? Change this to be pix map bounds top, pix map bounds left. Okay, then and remove this because we don't need to worry about that. Okay, and then in here we translate the destination rect by pix map. Oh, sorry, no, pick frame left. Those little debug prints are a lifesaver. That would have spent. Yeah. I'm glad that I did not have to infer what was going on, because that would have taken forever to figure out. Hey, alright, why are those still broken? I get there's no reason why those should be broken. We're back to where we were. Unless, of course... Oh, come on. What is going on? Why is the decoding step suddenly busted? Oh wait, it's because of this. It's because of this here, isn't it? That was superfluous, I'm pretty sure. Okay, those all appear to be decoding properly again. Now, if we look at this, we have... So where's the picture of Scully? Okay, so we've got the picture frame, which is... Yeah, okay. Okay. The logo's in the right spot. The lightning's in the right spot. Is Scully going to be in the right spot? Yes. And the fade-in effect works. Little zap is going to work. The line drawing effect doesn't work, but that's okay. I'm gonna let's just pencil that in as good, because that's pretty good. Not scene graph. What do you call it? Yeah, that'll do. Okay. Okay, now the final thing is this line drawing stuff. That, let's put in a breakcode. Sorry, a breakpoint. Because it's getting the line command, but it is not getting... it's not getting what we're expecting. Op short line. Right. So that pulls horizontal position and a vertical position. Okay, so how did I do it here? Short line, short line. Yeah, okay, so we get the pen location. And then we get two bytes. And I'm pretty sure they're all meant to be horizontal lines. So the fact that we're getting like weird diagonals is fascinating. So here we go. We've got our point. Yeah, and we have a 16 pixel horizontal line. And that does not appear to be what is getting drawn to the screen by a long shot. So we move to that position. Then we call the line command, which does a line from pnlock x to dh. Okay, yeah, the diagonal here should be a clue, but yeah, that should be y. That absolutely should be y. Yeah, in addition, we should be doing this in scene graph coordinates. Oh, sorry, X. Top. Yep, okay, so there's that. Also, I may go back into the prologue code. And increase this to like a bigger ops per tick. Let's go 32. Here we go, Fool's Errand. Look at that. Oh, it's very thin. It's a lot thinner than I was expecting. Why is it so thin? Oh, the pen size? Do we not implement the pen size? So you can see like all these opcodes here are about setting the, oh, you know, like calling the line command. I mean, that's not what it's meant to look like though. I mean, it looks like it's only drawing it looks like it's only drawing like 1 pixel of each of the lines. Like the horizontal, sorry, the vertical is showing, but it's only showing like 1, it's meant to be like 16 pixels across. Like, what is this? Why is it so thin? Well, it seems to be happening for all the lines, so we should be able to pick it out. Possibly it's because it didn't like me adding the coordinate offset. Oh, I forgot about those. Okay. Whatever. I forgot about the raindrops, but it's okay. We'll just wait until the image starts getting drawn and then we can be a little bit more inquisitive. Here we go. Okay. Okay, so we have yeah, it's meant to be like 5 pixels across. And we have, I see, okay, so we have a port rectangle which is off by 5. I mean, that shouldn't really affect it though, should it? Yeah, it should be still 5 to 10. Oh, bollocks. Okay, no, I did it too early. I forgot about this guy. I mean, actually, no, that'd still be... No, it wouldn't still be correct because it gets moved. Okay, so it should be like 1 pixel by 6. I mean, we moved both points by the same amount. I don't know. Okay. Yeah, so this was a mistake. I didn't... Yeah. This isn't the correct place to do this, because these positions are in surface, like surface coordinates. What I should be doing is adjusting the destination rectangle. Or dest pos, rather. Where does dest pos come from? Yeah, okay. Cool, alright. I'm confident, that should fix it. Okay, this introduction should be sound as a pound now. All these images seem to be decoding properly. Drawing at the right offset. Here it is. For no one can undo the treachery I've inflicted upon the land. And that happened at about a good pace. Yep, this looks fine. This looks fine. There was like a little bit of text that hung around on here. Alright, excellent. Let's... Okay, okay, move port to coordinate space. Okay, next thing I've got to do. Okay, now I gotta see if the game part of the game runs okay with the new PICT decoder. I mean, yeah, looks like it read the scroll on the title screen okay. Let's try one of the pictures, like if we go to the hermit. Oh, what? Temperance? Interesting, okay, so it's just not, The moon. That was the one I tested a lot. Okay, so this puzzle still seems working. It doesn't use pictures though. Let's see if I can just quickly solve this. Oh wait, no. Okay, turn them all on. Okay. Yep, that's one of them. Okay, that puzzle's fine. Is it the tower which has the puzzle? Yeah, okay, the tower does have a puzzle. Yep, which it draws in strips. Okay. So that's fine, I suppose. Okay. So what was the hermit? Was the hermit the polyomino puzzle? Yeah, okay. That's sub 142, 128. So I think that's the polyomino puzzle. Oh, no. It's one. Okay, that's 133. The star. Okay, let's try opening the star. Okay, and it caused a crash. It caused a crash because invalid rectangle question mark. Okay, 1950. I see. Okay, so maybe I decoded this poorly. Oh, I mean, alternatively, maybe this was... Okay, maybe we got to put a breakpoint here in whatever this is, sub 1284472, because it seems to be working fine for some puzzles but not others, but there are different bounds set each time. Ah, that's bitter. Sub 128. Okay, start. I'm gonna go to the star. There we go. So okay, I think 72 is maybe could be the number of the puzzle. Okay, so we have right that those pen sizes 0, 1, 2, 3, 4, 5. Okay, so that I think that's gives us the bounds for the little kind of rectangle zoomy effect, along with like an increment. Yeah, so there we go. We've got a rectangle in the corners. Right, and then so I see. Okay, so it's the so I guess it's like the final iteration, maybe, of that loop. Okay, not quite final. Penultimate, maybe. Oh, no, no, it is final. 41 is the final. Unless this is greater than, or just greater than. I mean, actually, no, it wouldn't make a difference. Okay. We're in the loop for A. AD. Okay. Well, it's definitely checking greater than or equal to this value here. Or rather, like, sorry, if this value minus I is greater than or equal to 0, and then you add I on that side and that comes back. Yep, okay. So there's nothing wrong with that part of the math. It's just the rectangle. The rectangle that came out the other end is just, it's wrong. It's dangerous and wrong. Okay, and I suppose we got like these, I mean, they've got this lower bound thingo here. Why just this though? This just seems very arbitrary. Zero, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I see. Okay. I mean, we can check that. What am I saying? What am I saying? Why don't we just make the quick draw API deal with it? I mean, it should be, yeah, it should be having kittens here, right? Where did it crash? Oh, it just crashed at the declaration stage. Did it? Yeah, I suppose it did. Okay, fine. yeah, we gotta do like we gotta sort out the oval drawing and everything later. Okay, that should avoid a crash at least. Okay, the star. Can we at least get into the puzzle now? Yes. Okay. So it filled the background in and yeah, it appears to be doing an event loop, which needs a delay. Okay, so 202. This looks like it's going to be expensive. Like it's calling picture like basically like all the time that the mouse button is held down. Or like drawing the picture to the screen. Star. Okay. Place all the they fix inside the black rectangle gaity in its correct position cannot be moved. To move a piece. Oh yeah, okay. So a long-standing issue is that instead of moving the drop down to an area where we can see it, it does this weird kind of half truncation thing. I have not found where in the code it does this 3 dots jib jab. Okay. And yeah, okay. A couple of invalid rectangles. Whatever. Yeah, ellipsis. Thank you. Thank you, Mad Moose. Alright, well we've done a bunch of work. I think we can let's do a little bit of coloring in, little bit of transcription. call it coloring in. That's basically what this is. Interesting. Okay, so we have this method here which calls either EB2 or FO4, and it appears to run into each other. So let's just go sub 33 FO4. Okay, and let's this sub 128.50E. Times 8 plus 3. This is interesting. Six eight A and 68C are generally like I and J in loops, which makes me feel a little suspicious about what's going on. Okay, it looks like it may be reusing. Oh no, 68C and 68A appear to be used as a global. That's confusing. But at least it's consistent. Times 8 plus 1. Where's the bit lot?